This is selected problems from 6.1 Intro to Log Notes. Some of these problems I'm going to do, some of these I'm going to have you do, kind of fill in once we do some of these example problems. We're going to try and keep this video short. So we're going to look at these notes, and this is our introduction to logarithms. And if you look at this first recall statement, we're talking about inverses, right? And normally when we do inverses, we switch the x and the y's, and then we solve for y. Now the problem here is we don't have an operation that can get y out of that exponent, all right? So we have to introduce logarithms, and logarithms will enable us to solve for exponents. So let's first talk about logarithmic form. Now the form itself, we're going to read this as, and then we got a little bit of clutter here, so let me move this stuff out of the way real quick. We would say log base b of x is equal to y, right? Which seems kind of meaningless right now. Let's talk about what these values represent. So the b is my base. That can be any positive number except for 1, because if you raise 1 to any power, pretty boring, it's always 1. The value is x, and we'll see that that always has to be positive. And then the y value is my exponent. Notice I don't have any restrictions on that. When we actually change from a log to an exponent, it's hard to understand what that log means. We're going to circle up. So what I do is I like to draw this circle up, and we slide over here, and now look at how this has changed. So we have b to the y power equals x. So basically, we get rid of the word log, the exponent and the value switch spots, and we're used to exponential form. So I think this takes a little bit of practice, so we'll just kind of look at how these things work. So again, basically we could say we drop the word log, and then we write the base, and we circle up the exponent and the value. And here, when I switch forms, this would just be 5 squared is equal to 25. And that actually makes sense, right? So when they're all numbers, it's pretty easy to figure that out. I'll leave number 2 for you to do. It's pretty straightforward. You're just going to circle up. Number 3, we can have negative exponents, right? And if I just switch this up and don't really think about it, you know, we might not really understand why 3 to the negative 4th power is 1 over 81. But if we slide over here, remember negative exponents give us reciprocals. So if I have like x to the negative 1st power, that really just moves that x to the denominator, right? And if I think about what 3 to the 4th means, it means 3 times 3 times 3 times 3, which is 81. This 3 to the negative 4th would be 1 over 3 to the 4th, or 1/81st. Okay, so we're gonna use that idea when we have negative exponents. Now to go back the other direction, we're still going to circle up, but when we're exponential and we're going to log, we have to add the word log. The base stays put. I like to exaggerate the tail on the g, so my 5 is definitely down there. The other thing I'll do is sometimes I'll put the value in parentheses just so I know that that 5 and that 125 are separate. And then that is equal to the exponent, which is 3. So the log, the 125, and the 3 are all kind of on the same level, and the 5 is like a subscript. So you could try 5 and 6 on your own, just circle those up and write them as a logarithmic expression. Now we're going to be evaluating expressions, and a lot of times in logarithmic equations, we change forms to try to interpret the problem in a slightly different way. So here, if I look at number 1, if I circle this up, right, log base 3 of 81 equals x, I might not really be sure what that means, but if I circle up and write it as an exponent, they're saying 3 to some power is 81. So what you can do is, what I like to do, because this will help us solve some other problems, is, you know, I'm asking myself what power of 3 is equal to 81. And if you don't know that 3 to the 4th is 81, you have your calculator. You can use this little caret key and just do 3 to some power. You know, you could try 3 to the 3rd, 3 to the 4th, 3 to the 5th, and there's just some guess and check there. A lot of times we like to write it this way, where we'll have 81, we'll change it to 3 to the 4th, and then we'll just say x is equal to 4. Okay, so you can do some guess and check there, but reinterpreting the form will be helpful. Okay, so you could try that. on some of these other problems. But some of these other problems, before you do these, make sure you add the equals x in here. Otherwise, when you circle up, it might not be clear what they want you to do. So I would put an x here and an x here, and then just rewrite those as exponents and see if you can figure out what the value of the exponent is that's going to give you the correct number there. Right, now, we're going to have some unusual ones, like when I do this one, I have 25 to the x power equals 5. That is strange looking. So what I'm going to do is I'm going to kind of interpret it like I did on that previous problem where I said 3 to the x equals 3 to the 4th. And 25 is another way of saying 5 squared. So I added that 1 in there because that's 5 to the 1st. And when you have the same base, you can ignore the bases and say, well, the bases are the same. I want those exponents to equal one another. And we end up with 1/2. So there we go. So we just want to get them to kind of have that common base. And that makes things a little bit easier. So you're going to try the rest of those problems. And even number 3, we'll talk about that in class, but that's an interesting problem. Now, the last thing we're going to talk about is, and this is going to be used in some of our more advanced solving, when you have a log of a base to some power, this log cancels out this base, and you just end up with the x, right? Same thing over here. This base cancels out this log, and you end up with just x. So on these problems here, log base 6 of 6 to the 8th, that log base 6 cancels out the 6, and we just end up with 8. Okay, this 3 to the log base 3, that 3 cancels out the log 3, so this would just be 11. Okay, now that seems like a bit of magic, but what's really going on behind the scenes here is if I change this to x and I circle up, right? So you can always circle up to reinterpret. I would have 6 to the x power equals 6 to the 8th power. Well, what would make those two equal? X would have to be equal to 8. So you can always circle up to reinterpret those things, but it's easy to think of them as just, the base cancels out the log or the log cancels out the base. All right, so make sure you finish up those other examples and we'll review those in class. Thanks for watching the video.